Okay, welcome to the last video. I honestly don't know how many I've made, but I'll figure it out when I look at the files. So let's go. Let's try and get all of these onto the very last one. Okay, the function h is given by this thing. Which of the following statements is true? Has the same in behavior. Oh, okay. So we need to. Oh god, we need to make this. We need to make this one fraction. That's going to take some space. So let me find a quick thing of scratch paper here. This will work. Why not? Okay, so we have to get these to have a common denominator so we can subtract them together, make them one big happy fraction. So in order to get these to be a common denominator, I need to take the denominator on this side and multiply it to the other side here. So we'll do x plus 3 over x plus 3. And then I'll take this denominator and multiply the big fancy version of 1 over here. So that's x minus 1 over x minus 1. And then I can, I think I'm going to have to FOIL all these out. Is that right? Yeah, so all of these are kind of expanded out. So we might have to go ahead and do that, which sounds lame. But let's see. So this is going to be, so on the bottom here is going to be x minus 1 times x minus 3. We'll FOIL that out later if I have to. And then on top is going to be 2x to the third times x minus 1. That's this side right here. And we can subtract, because we are merging these fractions together, 4 times x plus 3. So by doing this little fancy bit here, it gets a common denominator, so I can now merge these into one fraction with that one common denominator of x minus 1 times x plus 3. So these aren't the same. They don't have common factors, so we're just going to have to FOIL some of this stuff out, or distribute some of this stuff out. 2x to the third times x is 2x to the fourth. 2x to the third times negative 1 is a minus 2x to the third. Negative 4 times x is negative 4x, and negative 4 times positive 3 is a negative 12. All over x minus 1 times x, oh, this should be x plus 3. There we go, x plus 3. Let's see if we can avoid getting, let's see if we can get away with this. Okay, I guess I should FOIL this out then just to be safe. To rewrite the top here. And so this ends up being x squared, and then we will add 3 and negative 1 to be a positive 2x, and then I'll multiply negative 1 and 3 to be negative 3. Okay, so this is the correct equation. This is not the correct equation. This is... ugh. That's definitely not right. And this is not the correct equation either. So, it's A. There we go. It is A. Okay. Awesome. Number 10. It's the only one with the correct equation. The rational function, that thing, the rational function of h is given by h of x equals that thing. Which of the following describes the in behavior of h? So in behavior is going to be degree over degree. Don't need this anymore. So this is degree 5 over, that is a degree 2. The degree on top is bigger than the degree on bottom. So degree on top is bigger than the degree on bottom, so there's going to be no horizontal asymptote. And so we should figure if it is increasing to infinity or not decreasing to increasing to infinity. And this is much bigger. So I think we would have to put that into the calculator real quick. So we can hide this last one here. This one's called h of x. So we haven't used h of x, so we'll just throw in h of x is equal to the division of 2x to the 5th power plus 5x to the 3rd minus 2x to the 3rd, not to the squared, yeah, minus 13, all over 3x squared minus 2x plus 7. Okay, and we can scroll out, find some in behavior here. Ugh. So it looks like a quartic or a quadratic, not quadratic, cubic. So it's going to infinity up here. Yeah, I don't think it doesn't look like anything weird is happening. But it is going off to infinity and negative infinity. So as x decreases, y decreases, and as x increases, y increases. So let's look at our options. So yeah, it's going to behave like a cubic, because you usually just subtract those. So as x increases, y increases. As x decreases, decreases. So increase, increase, good, good, decrease, decrease, good, good. Okay, 11. The polynomial function p has 3 distinct zeros with a multiplicity of 1. Okay, so 3 factors, and its leading coefficient is positive. The polynomial function q has exactly 1 zero with a multiplicity of 3, and its leading coefficient is negative. The rational function h can be written as the quotient. So p is on top with its 3 zeros, so it has 3 distinct zeros. Okay, it has 3 distinct zeros, don't know what they are, but they are 3 distinct factors. And q has 1 zero with a multiplicity of 3, so to the 3rd power. Okay. Which of the following statements about h must be true? So the degree on top is 3, so this is probably horizontal asymptote. So the degree on top is 3, the degree on bottom is 3. Oh, it also has a negative leading coefficient, so this should be a negative on the outside of the bottom one. Degree of 3 over degree of 3, so it should be leading coefficient over leading coefficient. So it's going to be some positive number over some negative number, which it should be a negative number. That's all we can really tell. I don't know what the negative number is, but we know that it has to be negative. So the horizontal asymptote is y equals something is less than 0. So the graph at 0, no. Horizontal asymptote at y equals a, where a is greater than 0, so that's a is positive, no, because we know that one of those numbers is negative. Where a is less than 0, yes. No horizontal asymptote, no. So that one has to be C. Okay, here is another one. There is a little calculator icon, so we should be able to use the calculator here. Let's type in our function into the Desmos graphing calculator. And our function is r of x is equal to x to the 3rd minus 4x plus 3 all over x to the fourth plus 2x minus 4. Boom. So there is our really wonky looking function. Awesome. These can look really interesting. And so I have that typed into my calculator. And we look back over here. For which of the values, so we're looking for when r of x is equal to 0. So that means we need the x intercepts. So let's find some x intercepts. So we go back to our thing right here. And it looks like we have an x-intercept right there. We need to make sure it's an x-intercept and there isn't some hole in that spot that they wanted to get cheeky with. But it looks like that is not undefined for this function. So negative 2.302, whatever, that's an x-intercept. This one, no undefined there, so that is an x-intercept there. And then we have it right here. That is another x-intercept. So we should have 3 x-intercepts. Let's see what our multiple choice options are. We have at negative 2.30, that one is correct. And at 1, but we are missing something, so it can't be A. There should be 3. Negative 1.6, that wasn't on my thing, so it can't be that one. Negative 2.3, that one's good. That one's good. And 1.303, that one is good. So that's all of them, all 3. That's probably it. No. Okay, there's too many, way too many there. So it's got to be C. And again, we got that from, go back over to my calculator. We got that just from clicking on the x-intercepts, and it will just give you all the answers for you. Hooray. Calculator powerful. Okay, there's only 2 questions left, so we're going to put them on this video. The xy plane, the graph of the function, rational function f, has a vertical asymptote at x equals 4. Which of the following expressions could define f of x? So, it has a vertical asymptote at x equals 4, so that means that x minus 4 needs to be in the denominator and only the denominator. Right? Yep, x minus 4 should be in the denominator and only the denominator. So let's look at A first of all. So x, first of all, I have x minus 4. Well, after it's simplified. After reduction, after you reduce it. So here I have an x minus 4 on top, so that might not work, but let's see. I can factor a negative out of here because this is written kind of backwards. So I can factor a negative out of here. So this is going to be equal to, at least the bottom part is going to be equal to a negative 1. And because I'm factoring out a negative, I have to keep it to the third power. Have to keep it to the third power. And so that would make, I don't really care about the x plus 1, so I'm going to ignore that. I'm just going to work with this one right here. This will be x minus 4 to the third. X minus 4 to the third. And I have an x minus 4 squared on top. So what would happen there is that those 2 on top would cancel out. Only 2 of these 3 would cancel out, leaving an x minus 4 on bottom. So that is a contender because after I simplify, there is an x minus 4 left only on the bottom. Over here, this has, so this is going to be the same thing, only now it's going to be a negative 1 squared because this is squared. And then inside it will be an x minus 4 as I factor out that negative, and that's squared. But this is the same, x minus 4 squared. These are the same and the same multiplicity, so they would cancel out completely, leaving a hole. This one has more x, so as you can see, this is an x minus 4. An x minus 4 is this right here. This is squared. There are more x minus 4s on top, so it's not that one. And here, there are no x minus 4s on bottom at all, so it can't be that one. So it must be A, because there are more x minus 4s on bottom. After you simplify, it's left on bottom all by itself. Okay, last one. The rational function g is given by g of x equals that whole thing, which is then this. Okay, so what they did here is they went ahead and factored. This is difference of two cubes, and they went ahead and factored it for you. So this is going to be, that's one of our factors. This is going to have two imaginary zeros on it. Whenever you do difference of two cubes, these two are going to be imaginary zeros. So we don't need to worry about them because they're imaginary, and we're not dealing with imaginary on rational functions. Which of the following statements describes the graph of g? So let's go ahead and let's factor this. This is difference of two squares. So that is 10 squared is 100. So this will be x plus 10 times x minus 10. Okay, so the graph intersects the axis at x equals negative 10, because 10 to the third, negative 10 to the third plus 1,000 equals 0. So it does intersect at negative 10 because negative 10, well, it might not intersect. Actually, it doesn't, because negative 10s cancel out. There should be a hole at negative 10. There should be a hole at negative 10, not an intersection. So it's definitely not A. The graph has a hole at negative 10. Check. Because x plus 10 appears exactly once in the numerator and exactly once in the denominator. Check. When both the numerator and denominator of g are factored. Check. Okay, B is a contender. The graph has a vertical asymptote at 10 and negative 10. Well, those are both excluded values, but again, this is a hole at negative 10, so it can't be C. The graph has no holes because the degree of the numerator is greater than the degree of the denominator. That doesn't even make any sense because the degrees have nothing to do with the holes. So it must be B. And that completes the study guide. Good luck. Ask me questions tomorrow. It should be awesome.